If you just joined us, I'm Kevin Krutz, Turtle. I run the data center segment of our business, as well as some mega projects and national strategy as well. And so joining us, Bill, would you like to introduce yourself?
Sure. My name is Bill Haas. I'm based in Chicago, Illinois. I'm a senior vice president at WSP, where I work particularly on sales strategy and growth, as well as some project support for decarbonization projects and transportation electrification projects.
Awesome.
Yeah. So, okay, that's James McRoy. So, based in Raleigh, North Carolina, and I lead up our sales team here in North America for energy transition. So we're focused on everything from decarbonization of homes all the way back to utility grid. So working in that capacity to, as we're talking about here, kind of collaborating. I think the people gave their background a little bit earlier. I'll give you a little bit of mine because I feel maybe a little bit old to say, when we talk about like microgrids and paralleling, I heard somebody up here talking about small nuclear reactors. I thought back to my time in the Navy. I did Navy nuke was what I did in the career. And we had an aircraft carrier. The first nuclear aircraft carrier was the USS Enterprise. Now, it had, I think, 6 nuclear reactors on it. Now, we realized that wasn't a good design because then we went to the Nimitz class and we had 2, right? 2 large reactors. Maintaining 6 was a little bit of a hassle, but that just made me remind me of that. So I feel like I've been doing kind of energy transition if we put that in the category for say since 1990 something.
There you go. Just round it off, right?
Just round it off, stuff like that.
I mean, that's definitely the conversation. I mean, if anybody knows about the Navy nuke program, it's one of the leading around the world, right? So how are we able to get into nuclear reactors right now? If you're a Navy nuke guy, your resume just went through the roof because everybody wants you, right? So thank you for joining us, both of you guys.
I think you should give a little bit of your background as well. You've got an interesting background.
Absolutely. Background for me, I kind of started off in distribution design, working, in Colorado. I learned from my grandmother, who was the chief engineer, Hewlett Packard, as well as my grandfather was the GC for NORAD. So all the tunneling, the entire design of power going into the mountains, he did all the design on that kind of stuff. So I felt like one lines and some of the drafting was kind of just innate in my abilities. Did I do that the rest of my life? No, not so much. But I did get right out of high school, did not go to college, went straight into the trades work, doing that type of design, drafting, AutoCAD, 2020 designs, things like that. And so I felt like I had a career right off the bat, went into a company called HD before it was split off and resold 6 times. By private equities and things like that. Military logistics, I was picked up when I saw distribution and companies getting bought and sold faster than I can get a paycheck. And I was like, okay, I went into the military logistics supply chain, ended up being a battalion liaison officer across Afghanistan, Northern Iraq, and also the Horn of Africa, working with the chiefs of the Army, as well as Colonel, mainly doing logistics and supply, building. The Army, I always said the Marines would blow stuff up and the Army comes back with all the engineers and build stuff back again. So did a lot of building. Any Marines out there? Sorry, I should have asked. But no, absolutely enjoyed that very much. I got a call from my wife while I was in Afghanistan. Thank goodness for AT&T sat phones. It would bounce across every network across the world for $20 a minute. And my wife called me at the bottom of a mountain and said, "Hey, what are you doing?" And I said, "What do you mean, what am I doing? I'm getting ready to go figure out why our supply chain's cut off in this region." And about that time, everything started breaking loose. So I had to hang up with her. Sorry. Can't leave with that one. But what I did is realized that in the military, what we did was we connected countries, organizations, third country nationals, corporations to build modern cities all around the US. And that's what I really enjoyed. And I always thought of myself as like being that chief. So I was planning on going to chief school. My wife had different plans for me. She said, "It's time to start a family. Let's start a family together." She was born Fort Bragg, so you know that area really well. And I thought, okay, I'm going to stay in the military. Fast forward, after 6 years, I joined distribution again, started running utilities, in the distribution world for Entergy out of the South, Evergy, for, it used to be KCP&L out of Kansas, as well as American Electric Power out of Columbus, Ohio as well. And did projects with Southern Cal Edison as well as Con Ed, Duke, to name it. So that was probably for the last 20 years. And also now with Turtle for their national and data center strategy across the verticals. So thank you for all joining us today. It's been fantastic so far. I've got to listen to some really good commentary, and thank you, James, as well, and Jane, for making this possible. WSP, what are your thoughts about what's going on in this industry and how we're working together?
Well, if we look at, say, specifically the transportation electrification side of this industry, what you have is the intersection of two previously discrete disciplines and infrastructure systems. The energy system managed by the utilities and those supporting contractors and that supporting workforce. And then you've got the transportation system managed by a whole different set of engineers and departments of transportation, locally, regionally, nationally. And all of a sudden, they're coming together. But you're putting these two groups together that don't really and haven't really yet worked with each other. So I think that's one of our biggest barriers to advancing decarbonization through transportation electrification is getting those previously discrete systems working together.
Yes.
And there are groups that do that and are doing it. And I think part of that is why planning is so critical. So upfront planning that involves a significant amount of stakeholder engagement. So you can bring those stakeholders that might not have ever worked together. The also thing that I like to always include is making sure that the community has a voice, because this is all new to them as well. And that helps overcome some of the anxiety that people might have. And I'm pretty darn bullish on fleet electrification. And it was said in the previous panel that it sounds like a lot of people in this room, and definitely the prior panelists are. I know you guys are. So that's my perspective on it.
And Bill, what's Eaton doing?
What's Eaton doing? I'll build on what Bill said. I mean, from an OEM perspective, what can we do? We look at it in a couple of different ways. Probably the first one I'd start with is like integrated solutions, right? Our ability and the things we've been looking at to say, how do we take all of our equipment from best battery systems to EV charging to microgrids to intelligent power distribution and all that work together, right? Because that's what the utilities are telling us, what the customers are telling you we need. How does this all connect to solutions? Heard earlier somebody talk about skid mounted solutions, but get those things to market faster. But it starts with us kind of integrating those things in and thinking of more innovative ways to come to market with product, as opposed to just the old style of you had to go buy it here, you had to go buy it here, right? Sitting down with a customer and really listening to what are they trying to solve as a problem, and maybe sometimes thinking about new solutions with them, right? Getting engaged early has been really kind of a new deal for us. And I'd say partnerships is by far in the last 2 years something you probably have seen us do. You've heard some announcements, right? We buy things, but we're not just buying anymore. We're investing in some of these really smart companies that we can partner with and help them innovate, because the problem's not solved yet. Right. For me, collaboration is not an option. It's a requirement. It's become the new standard. This way you have to do it. I mean, you have to stop me from talking because I love this.
Hey, go ahead. Absolutely. It's a great subject.
A good example is I was talking to somebody from Georgia Power. I said, when would you have thought that Siemens and Eaton would partner? We made an announcement earlier this year, Siemens Energy and Eaton Electric.
Huge.
Everybody's like, what in the world does that mean?
Two generals coming together.
It's like,
Right? When does that happen?
and if you look at it, the data center team up here was talking, how do we get power faster, right? That's that autonomous data center. Siemens has a, nice size gas generator, partnered with some of our distribution equipment. Boom, we think we can take maybe 2 years off, if you read it, off of getting the data center online.
And building on a point you referenced the prior panel, which talked about the modularity of some of this equipment. And I think to actually scale this equipment, whether it's modular microgrids, modular battery energy storage systems, there's some modularity to electric vehicle charging systems, is incredibly important. It also allows you to not over-engineer upfront, which is how you speed things up and keep costs down. But you also need to be able to future-proof so that's truly a modular system, so that when it's time to add more capacity or what, that you can do so. So you deliver projects and solutions much quicker, more quickly that way.
For those that do not know, explain a little bit about what the Siemens option with Eaton, what that's doing currently, and what you guys see next.
Sure. So if you think, and I'm not the gas expert, but I've talked to some people in this industry, we talk about energy transition, right? You can go talk to a Shell today. They're still thinking about it, even though they're traditionally an oil and gas company. But usually getting a gas pipe in is a little easier nowadays than getting capacity from a utility. So if you can get a gas pipe in, right? Siemens, the partnership there is they have, and we're with Siemens Energy, we're not with Siemens Gear, right? There's two separate sides of their business. But we're not selling that. We're not running through our books. It's an integrated, really, I'd say, design with our engineering teams to exactly what Bill said here, deliver something that's already solved the problem. And so that, it's a natural gas generator. I think they go up to 500 kW. That thing can be put in. It's got some of our distribution. We integrate it with battery energy storage. And so really a full packaged power system that a data center can put in, and boom, we can start populating servers. Why? Maybe we're waiting on the utility to get there, right? And then it becomes an asset that potentially is utilized. And that's what data centers and kind of, if you talk to utilities, they're saying, okay, at some point, we're going to have kind of some data center aggregators. We're going to have potentially EV aggregators because there's going to be this installed base of EV vehicles. So did that answer kind of how that?
Yeah, no, absolutely.
And I think you also made another point that is worth discussing for a minute, is that getting service from electric utilities is just such a long lead time. So, and if we want to accelerate these sectors and deliver solutions, ideas like that for data centers, for EV charging, it's the only way to do it and get around the utilities, because the utilities are used to their process.
Sure.
And they're in many cases regulated, and they have to follow that process, and studies with the interconnects at time. So there's a lot of pieces that have to be done in a very linear fashion. So if you can deliver power on site and get away from that linear fashion, and I think we'll see, again, the whole idea is how do we make this happen more quickly while delivering the benefits and making choices. And that's what I was talking about at the beginning with sort of stakeholder engagement. Part of that process is define the problem and develop the metrics.
Yeah.
Think about how you're going to measure those metrics, and then you can apply them to your decision-making process. So you're making decisions that are adding the most value for the solution that was planned for at the beginning.
And I'll add on to that, like, 'cause I heard some of the government stuff, and I have our government team as well, but I'll give some good to our government. If you go out there, this team should go look at DOE. I can send it out. They just announced like an RFP, I think for 6 of their sites, to work with AI data centers to accelerate that. They're going to talk about nuclear. One of them's Oak Ridge National Lab. And because of our relationship with DOE, and you ask like, what are we doing? Like we start back there in that kind of this journey of talking with DOE officials, right? We have that luxury as a company based on our size to really help maybe influence that, but also collaborate with them to say, how are we going to solve this problem at the end? So it's just a plug for them that they are trying.
Yes.
Department of
They are.
Energy. They are trying.
I think I even mentioned it to some of the spectators as well. Like,
Okay.
there's some hope.
Yeah.
I saw that as looking at it in terms of the backlogs that you spoke about, going down that line of 3 years, that, regulated power, that, and it's almost it's a bad, almost like a cuss word for the last year, right? Regulated power. And so, especially if you're from Texas, we're my Texas people.
I'm originally from Texas. I didn't. Purple over here.
Absolutely. But just looking at it in terms of the going through the this used to be standard, right? That's easy for a utility to go what used to be their process and their standards. But now for tomorrow, how do we do things differently?
Sure.
So like you were talking about Siemens Energy, Eaton, Bertle, we do things very differently than we did 5 years ago, 2 years ago, 1 year, right? And so any thoughts in the audience of how we can do things differently for the panel? In terms of, yeah, go ahead.
Lead time for gas power generator deliveries.
I do not know. I'm sorry. I should know. I don't know. I can look that
Your
up.
question is, what's the lead time?
Yeah, what's the lead time and how can?
100%. So lead time right now for a 17 megawatt gas generator to go on a gas line site is approximately 9 months. If you're working with someone, the majors, say if it's GE Vernova, their 34 megawatt turbines are now almost 3 years waiting in line.
Bigger units.
Yes, that's the larger the unit.
A plus.
Most of the Siemens units, also 50K plus, are very popular out in the market. That's going to be a 2.5 year, also waiting in line. What's nice about the turbines is that they're 747 jet engine, right? So they're designed for extreme use. The FAA would have never approved those on an airplane if they weren't designed to just run without problems. Unless you were American Airlines and DC-10s, right? But we're not going to go there. But I was just looking at it in terms of how do we work in those terms? Well, we just talked about that. Transformers take 3 years to get medium voltage transformers. Am I wrong?
Some of
I was just gonna bring up, I was just gonna bring up the same thing, because it was, okay, so that's taking the same time as your interconnect, but if you want your transformers, you have to wait 3+ years.
Absolutely. And so I think the way we look at that is working through partnerships, just like Eaton announced with Siemens Energy, just like Turtle announced with over 28 suppliers across the data center industry and the energy industry. We're shipping that stuff. I'm not going to name exacts, but we're shipping that stuff in 6 months, 9 months. Doesn't sound like 3 years anymore. So we're able to do that with radical collaboration around the world. And as a distributor, we get to work with our partners very closely and collaborate on how things are working, what the design needs to be. So there's not that over engineering at the front end. And then we can start looking at, hey, where's the transformer? Where's the distribution line? Whole 9 yards, similar to what Burns and Mac was talking about earlier, about looking at the end and working it back and reducing those lead times in the market.
And I would add on to that. I mean, don't sleep on the fact that we as a manufacturer have service and application engineers, and we want to be plugged in. We see the benefit of being plugged in early.
Absolutely.
And, that doesn't mean we're trying to do somebody's design job. We're not stamping drawing in
Sure.
an AE firm. But we do have people that could look at your scenario and say, maybe something in your spec is driving that lead time. Right? I can give you a simple example. Matter of fact, that's where I know WSP from. I'm working with them in the Postal Service. Somebody put a spec together that said they wanted aluminum bus. I was like, wait a minute, right? We're kissing that thing out here. And where's it going? Waco, Texas. Why do you need that?
Yeah.
Oh, we don't. We just cut and paste it. Not a mistake. It's
Sure.
just somebody just did that because they were probably in a rush getting it done. But having one of our application engineers look at it and go, look, we could get that out next week, right? From a switchboard, panel board perspective, if I don't have to send a bus off and have it special dipped because we have all this in stock. That's a simple example of something that early involvement can, you both said, not over design it, but also might value engineer it.
Sure.
Not just from a technical perspective, but meeting some of the things that we have from a lead time perspective that can meet your need, right? A little bit more creative in what you're doing.
Reuse, okay. The automotive guys, they remanufacture engines, transmissions, things that have long critical path, high cost, right? Now that we mandated use tires, you have to responsibly dispose of them. You can pyrolyze them and turn them into carbon black that's recovered and CHP to energy. Do we have any of those things going on with the transformers, or what if the big critical path is to use them and incorporate those in the modularity that Bill and James have talked about?
All the above.
Yeah.
Absolutely, right?
I mean, there's companies out there redoing transformers, some about Solomon. I think,
Rewinding
was one, or
Yeah.
rewinding them.
Absolutely. If you look at the bushing or, the giant transformers, when I say giant, we're talking about, those massive semi transformers that are coming down or being hauled on a train, to develop the huge MVA high voltage level stuff. And one of those might take 3 years because of one little part. Because it got spec'd in another country that had a fire, and that's creating the entire backlog of what's going on in the industry. So being able to mitigate risk by having multiple suppliers of similar designs is key in the market, as well as working with our global suppliers and our network across our OEM, our relationships and our different global partnerships that we've created in the power industry as well. And it's really about what I would say is doing something you're not used to, but having faith that your partner knows that with their proven track record, that they know how to help the problem and work together for those solutions.
And I would say on the consulting and design engineering consulting side, there's also some opportunity for modularity there. But it also, to your bus bar point, not everything can just be cut and pasted in, but there are efficiencies for what a WSP does that can be gained. And I think it comes back to the modular equipment, which has modular engineering designs along with it. And then you can just plug and play.
Absolutely. And I mentioned, I think, Asia before. If you spend any time in Korea or any of those places, you'll see what we're talking about. Their systems. It's just like they're picking up a Connex, plugging it in, picking up another one, plugging it in. Oh, we need to scale more, and they just keep adding. And that's that. I look back at it and I think of Legos, right? Building blocks. That's what we're talking about. Fast forward 30 years, didn't think I was going to be playing with Legos again. Right? But we are. We're taking those systems and we're plugging them all together, just like one after the other. But the good thing is Turtle, Eaton, WSP, Burns and Mac, we have engineers and people that are much smarter than this guy on staff that put those things together to make sure they don't go boom. The Army tried to do that with SMRs back in the day. The Navy nukes had to take that over. The Army didn't do so well. Am I wrong?
You're not wrong.
Exactly. Voting names. No, I like to have fun for sure. But
I had a question for the
Yeah.
group. I was talking about stakeholders, and you should know I have a background in policy. I'm not an engineer. I just pretend to be one.
Sure.
So I started talking about stakeholders, and I'm curious what you all think the role of government policymakers and utilities should be in potentially addressing that linear approval process. And if there's any solutions in your work that you've come across, and you as well, since you run the government shop too.
He has the audience.
You did ask the audience. Go ahead.
So I work in Bob later. I also have a solar company that is modular, and I talk about our product actually being the Legos of solar. We actually just did a 2 megawatt system in 1 week with volunteers and day laborers. So we built the system faster than it took the fence company to put up the fence. Frankly, one of the challenges we've had is because we're a new product in the market, big EPCs send us over to their engineering department, and the engineers don't see metal and steel and nuts and bolts in the traditional system. And we immediately get the question about bankability thrown back at us. When to your question, that 2 megawatt project that we just did actually didn't need a building permit. So one of the ways that we're trying to help solve some of the permitting challenges and some of the regulatory red tape is actually by simplifying the installation process. So I'm just kind of curious, I'm like, how do you guys think about internally about rethinking some of those processes? Because James, to your point, I mean, I had to push our engineering electrical team to say, no, keep modularizing. Like we have a module, system solution, but modularize the one line diagram, right? Give me 75 kW block, give me 150 kW blocks. I want to plug and play these things as fast as possible and rinse and repeat on almost every, situation that you can. And so anyway, it's a comment, maybe hopefully your question.
Do you want to take that, James?
Trina, do you have anything to add?
I guess I look at it broader brush and I'll let Trina go, but I I feel like regulators, and to your question, like how to get through that process, they're even opening up a little bit to have discussion, right? So from us, it's a trade association, sometimes conversation about actually changing code. And some of that gets maybe into what this team may not, but like you look at the residential and getting to where a software, right, regulating, what's going on in your panel in your home, you might be able to overload that panel if you look at it on a wire and on a drawing. But because of the software, we're not in the hardware is part of that, but it's not, we're gonna be able to regulate the power out of that panel. Right, so we got a 200 amp panel, we overload it, we might be able to regulate it. We've got a transformer sitting out here and all of a sudden people start putting chargers and doing electrification of their fleet. You're seeing regulators say, okay, if I can throttle that because it's a standard protocol, then yeah, we can kind of overload a transformer. In old days you would, right?
Mhm.
And so those types of things, I feel like they're opening up if you're talking to them early.
Yes. There's a lot of trust to be built. Do you agree?
Sure. Bill's picking at me, as he knows, I'm another fellow policy person in the room in the energy space, but I think all the pieces that we're hearing I completely agree with. I think the earlier conversations with a diverse set of stakeholders and the time it just takes to do that. So these are large organizations, regulators, utilities, government that aren't used to changing or not used to changing quickly. And they rightly have safety, procedures in place because that's what are necessary for them to operate. And so getting in those conversations frequently, finding the right partners within those organizations is really key. And it just takes time and effort, but it won't change without those types of spaces and collaboration. So we've heard a lot of those themes throughout the morning here. So I just echo that.
Anything on that one?
No, I think it's been really well covered.
Absolutely. Awesome. James, what role do you see us as a distributor, WSP, Burns and Mac, as what roles do you see us all playing in this?
Well, you're the conduit for us. No, as far as playing the role in this, I think a lot of it's been said, right? That collaboration, but pull us in early, right? And say, and help us even, we may not have innovated enough, and that's okay, right? We are, again, we're looking different than we looked 2 years ago. Right. I think my team existed 4 years ago when it started, right? We need to have an energy transition team, focus on this and saying, hey, how are we going to solve this problem? And so the role, at WSP, us having conversations together, connecting and I guess I hesitate to say you have to do something because I feel like it's happening, right? I go to some of these meetings and I'm talking to Schneider people.
Right.
About this, right? And we're all in the room, and it's probably at certain levels, right? I'm sure an individual salesperson sitting down there still fighting it out in the trenches, right? Over it and mad about their competition.
Sure.
But we sit in a room together and we sit on committees together. And, I mentioned trade associations. For us, it's NEMA.
Right.
Right. And so what role does NEMA play? What do we play when we go to a NECA conference with contractors and distributors? Sure. And those things are important to us to collaborate to say, hey, what are we doing next? And you need to hear, right? I'm not here to say we're going to get better at lead time, but you need to hear what we're doing, right? And hold us accountable to, hey, did we fulfill the promise we said we're going to do, right? We're on that journey. I hear lead times. I hear that operations excellence, and, you can go read it in the publications. We've invested tons of money, right? This caught not everybody, was ready for all of this. And so when we had to come around, you could see we've invested in. The lead time come down tomorrow? No, but we anticipate them coming down sooner than later, I would say, right? Maybe not transformed by themselves, but but letting us know, I think back to your question, let me just get to it. Helping us not be, and I heard somebody earlier say, this can no longer be a vertical construction brand. You have to allow us to talk to you about, can you lock in the transformer? Because you know what size your site's going to be.
Exactly.
Boom, let's go. Yep. Right? If you can lock down something on your gear, boom, let's go, because you get us a PO, maybe it's hold for approval. And we say, hey, the gear is going to be 17 sections. We still got to modify some things, but let's reserve a slot.
Exactly.
Right? That's how you can help us, is let's reserve a slot. We kind of know the scope of the project. Don't wait till we're at 65% design to say you need something.
Absolutely. It is definitely a theme of radical collaboration between all parties, everybody involved, making sure that we're all working through the visual project of what it looks like. I mean, Burns and Mac, you're talking about the beginning to the end. It's the same thing. When you look at the thing as a whole, you bring in your partners. Everybody sees things a little bit differently, and that's the beauty of collaboration. Is being able to work through those because looking at a project that might take a factory, Eaton, Schneider, ABB, 60 weeks. That's where the value engineering sometimes gets done ahead of that, where we work together on those plans and we hand it over and it saves them 17 weeks out of that project being delivered just by that collaboration that we're talking about.
This level of scarcity globally in equipment to accelerate the energy transition, it can often create innovation and new competition for you guys. And I'm just wondering, what is Eaton's plan to address the shortage? Are they looking at onshoring more in the US?
As far as just from a manufacturer perspective,
Yeah.
I mean, if you look at the story, we've invested almost $1 billion in expansion, right? So our Waukesha plant, we expanded down Nacogdoches on transformers. We got a new plant going in down in North Carolina. We put in, one of the things that got us bottled up was probably our breaker plant down in Puerto Rico. If you look at that, we talk about energy transition and kind of walking our own walk, right? We put in an entire microgrid in our own place, right? Because what does that do for us? We don't lose 2 to 3 weeks from Puerto Rico. They don't have this most stable grid in the world. But not only did we reduce a carbon footprint, but we also said, hey, this thing's more resilient. We can keep operating. Regardless of what goes on the grid, that will run our entire facility. Right. So things like that we're doing. Supply chain wise, I mean, diversifying our supply chain just like everybody else. Right. And putting together, we're also going through these journeys of SAP and the back end systems to make sure we know what our inventory is. And so really, if you listen, it's operations for, growth. And so we're dedicated to that growth, what we're doing. The other part is, like, I come back to partnerships, right? Things that you talk about, how do we bring other people in? We did acquisition of the extra resilient power, right? That's a little bit of a capacity, but more of an innovation piece of how do we get to this new, like a solid state transformer. That's going to be pretty impressive when it's out. But yeah, I don't know if that answers your question just from it's investment for us.
Absolutely.
A little bit of follow-up question. Have you considered manufacturing on your own scarce parts? Like during the pandemic, Tesla was building their own microprocessors so they could continue to deliver cars. Have you thought about something like that or acquiring somebody that might do that?
I've not heard us talk about doing like the chips or any type of manufacturing like that.
Not necessarily chips, but any parts that your suppliers may not be able to procure.
I've not heard us doing that from a supplier perspective. I mean, most of our parts, we make our own breakers, make our own vacuum bottles, right? The majority of that we're doing steel, we stock. We don't, necessarily roll steel. That's just flat steel that comes to us. Same thing with copper. We're copper, anything like that, melting pots. But most of the smaller components we make, most of it's had to move to like different locations just based on, if we put the elephant in the room of tariffs.
Sure.
We got to make sure we cover that as well. So where that goes, not to talk about that with a policy.
You said it, I didn't.
No, but these are all great questions and things that we've actually stood up a full team to look at this, right? And so if you look at what our president Mike has done, he said, look, we got to fix this. And he pulled people out of senior roles. He's pulled people out of like regional vice president roles and said, hey, you're coming back to operations and this is what we're going to stand up a team, as opposed to a plant manager having to figure it out by themselves.
Right.
Right. Because in old school, we said, we want a plant manager. That's our future leader.
Sure.
We want him or her to run their business like it's their own autonomous business. We realized that didn't work for us, right? Especially in this environment. So we had to pull back, have people to help him, and at the same time, connect him with his other 16 plants so that we know our inventory. Right? So that part shortage might be at a plant in Atlanta. We might have it in Phoenix.
Right.
And so we have a system that tells us now we can get that part, right? It's not always, again, we probably operated a little bit, I wouldn't say silos, but every business intentionally, we want them to run their business. We operate them as separate P&Ls and all those things. All that's kind of been pulled back together. We pulled some of the, profit piece that we got a plant manager worried about. He or she now had to worry about operational excellence, right? So those are intentional changes that they're disruptive in our business, but they're needed.
So that's an interesting example. The old way that you were doing things
Mhm.
is how Caterpillar works globally. Every one of their plants is a separate P&L, and they don't have any communication. And I've done energy efficiency work and renewables opportunities with Caterpillar. And it really comes down to one plant and that operator manager versus another one. It's just an interesting model because it seems really inefficient.
Yeah, it's a change for us. I mean, we can get an order turtle when it's theoretically be manufactured, if it's a panel board switchboard here, or if it's a standard one to be in Sumter, South Carolina. You might get it from probably not all the way to El Paso because we just opened 2 new plants in El Paso. That'd be a little bit long, but it might shift down to Raleigh, right? If that's where we have the capacity, it's going to still make your delivery date. If that's all kind of happened in that background ecosystem.
It's a huge change, right? I think COVID may have pushed us to that, right? To those
I
type
mean,
of changes.
I don't remember the phrase, but what's the, push for innovation is when you got this problem.
When there's a catastrophic issue, absolutely.
It's been hard, but I would say it's been fun for some of us.
Sure.
Some people probably are not calling it fun, but
But
it's
so on the operations side, I'm sure.
it's a math problem. Everything's a math problem.
Any questions before we conclude? So, well, anything you guys wanted to add? I think we're down to 5 minutes, so.
You mentioned the risk of almost over designing these. Just expand on that a little bit.
So oftentimes when you're doing preliminary design and you're looking at a project in its entirety, engineers without good oversight can spend too much time upfront, burn through too much of the engineering budget for the project upfront, and then you've got more than you need for the completed project. You have 60% of the project's done, but you only need 30% of it when it first comes operational. That's where there's methods you can do to make sure you're not doing that, except for the point where you do so that you can expand or you can deploy the full project. So that's what I meant by that.
And are you seeing people acknowledge that and work differently, or is it?
We talk about it often on our project management and design teams to make sure that we're meeting the needs of the client, we're managing the budget, we're giving them the drawings that they need when they need them.
That's one more question. You started with nuclear reactors.
Sure.
Where's the status of the technology, small nuclear reactors, modular reactors? Are they scalable? How soon will it be something that's viable?
I think sooner than we expect, right? And the places I talk to people, I mean, you have people that are already standing up. How am I going to install these, right? Now people are making them. I've met people who started companies that say they're already working on designs, put these things in pylons, bury them in the ground, and then they have to distribute that power. So I think, is that 4 years, 5 years? I think it's sooner than we think.
Absolutely.
It's because it's already, people were, like I said, when I heard that, I'm talking to people, to your point, the government's working on it. It's coming.
Absolutely. I definitely think it's, I used to say 5, now I'm saying more like 1 to 3, depending on which budget gets thrown at it fastest. So as we learned in the South that the SMRs are definitely taking root. And it's really that scalability comes after that. Absolutely. Well, thank you all. Appreciate. Oh, one last question. Sorry. Sorry, repeat that.
He said, like, what's the shift and like,
Shift.
full power for data centers?
Not, I would say it's not going to happen as a whole. The grid is there for the reason, right? For stability. Bridge power, if you're referring to generating your power outside of the grid, then, I mean, that right there is, it's about parts and pieces and supply chain of those items. So if it's not the utility you're waiting in line for the interconnect on the utility for 2 years, you're then thinking about what does a turbine weight? Are you now in line for a 3-year waiting list to get 34 megawatts or times 7, right? I mean, if you look at what's going on in Ohio and the Midwest right now, they're they're gobbling up as many turbines around the world as possible, right? I think I was on calls with Dubai and some different places in the Middle East that we had military bases with turbines, generating power that they're going to recommission and bring back to the US for projects, right? So I think it's happening more and more as a necessity to bridge the power problem with the interconnects.
And I'll just add one thing. I know we're probably out of time, but we didn't talk about it, but we talked the big projects, which are awesome, right? But this problem is more than just the big projects in AI. And I shouldn't say it's a problem. It's cool. We want to decarbonize. For people, look, I think electric vehicles are here to stay, but they're going to add a load, right? So
A big load.
A big load, right? And so when we look and we talk and we start doing innovation, it's ways to make what we have more efficient.
Right.
Right. So there's software ways, there's hardware ways. There are things that we're trying to do to maybe offset what's going on over here in the data center so that utilities, right, when you talk to them, they want to focus on this. Look, it's money. It's big money for them, right? They want to sell that power. But over here is we still have this decarbonization initiative that's awesome, right? I'm a believer in it, regardless of what anybody else says. Go talk to somebody, and I know we don't like to say it, maybe in New York. Let's say in California. No, just a quick story. I was talking to the guy the other day, right there at work, and he said for the first time, however many years ago, he could see the mountains out the back of his house. So why don't we hear that?
Right.
Right? Because I'm thinking, people think this doesn't work. That's huge. That's huge. Now, you used to go to California years ago, just gray in LA.
Right.
Like you never saw the sun. They call it sunny. It is not sunshine. And this guy now can see the mountains. And I asked him, I said, well, why don't we hear that? And he goes, well, if you start anything that says, well, in California, everybody probably shuts down. Right? But the facts are, it's proven.
Yeah.
The initiatives they've done that we're doing now across the United States, heavy involved here in the Northeast, that really make an impact to this at the end of the day. I know we talk about power scarcity, but I just didn't want to, that decarbonization and the energy transition, that's a passion we should all have.
Absolutely.
Because it definitely makes an impact.
Thank you.